Anybody ever watched any of your other teachers record anything? I just want to see how it works, see if I can actually do it. Check through the answers. Should only take a couple minutes. Knock it off. Also on Moodle, make sure you're getting on Moodle looking. Sometimes right now, I messed up last time. There was, we were supposed to do something with section 6.2. We were supposed to do a little homework assignment on Moodle. I'll probably get rid of it too. It'll probably take me a while to get used to doing this extra stuff. And by today, there should be a video that you're going to have to watch so that I don't forget it at the end of class. There's going to be a video on Moodle that will go through some of the worksheet that's going to be your assignment today. So watch that video, then there's a short quiz at the end of the video. Do that quiz, and that grade will be put right on Moodle. Make sure you do that before next class along with the worksheet that's going to be the assignment today. That question 20, is that the right answer? 15.525, or did I mess up and put an extra 5 in there?
I think it's right.
I think it's right.
Yep.
Just the others are 7.5. It looks like that one will probably be 15.25 instead of 15.525. All right, questions. 293, problems you want to see work? 14. Problem 14, and it's been a while, so make sure you're asking questions. Don't, make sure you follow along. Problem 14. Says, determine whether each pair of figures is similar, justify your answer. For these two figures to be similar, did I forget some other stuff? Yeah, somebody wrote in my book, so I can't tell
what the actual marks are.
D. For these two figures to be similar, what we're wanting to do is show that the angles, again, two main things. Angles are congruent, corresponding angles are congruent, corresponding sides are proportional. So we look at the angles, we have these two angles are congruent, these two angles are congruent. What's that tell me about angle C and angle N? They have to be congruent. All right, if we had a theorem a while back that said if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must be congruent. Now, we match these up, and the easiest way to match them up when they're giving you something like this, which we won't be able to do after today, but it's just to match up the longest side here to the longest side over there, shortest side here to the shortest side over there. And we're just going to set up ratios. And they should all be equal to each other. What's the longest side in this first triangle? 4. So it should match up to what in the other one? 10 and 2/3, very good. What's the shortest side? Let's do the shortest side in this triangle.
2.
And it should match up to 5 and 1/3. And what's the middle side in this triangle? And what's the middle side in the other one? So we have all that. Now, probably the problem most of you had with this is they throw in all these fractions, and that makes it a little tougher. 3/8, will that reduce any? So that's done. We can't do anything to that, but we need to reduce these down. If you get out a calculator, and it's got the ABC button on it, it could do the reducing for you. If you got one of the TI-83 calculators, you can use the math button and the fraction, and it'll do it for you. The way I would probably do it, instead of grabbing a calculator, is change this into an improper fraction. 10 times 3 is 30, plus 2 is 32. So this fraction is 4 over 32 over 3. Whenever you're dividing by a fraction, you're actually multiplying by the reciprocal. So you're still the 32, what's gonna happen is the 32 is gonna stay on bottom, and you're just gonna multiply the top by that 3. So what's 4 times 3? So we got 12 over 32. What's 12 over 32 reduced to? What'll go into about 12 and 32? 2, anything bigger? What? How about 4? 4 will go into 12 how many times? 4 will go into 32 how many times? Is that the same as what we have over here? So far we're all right. Do the same thing on this one. 5 times 3 is, it's 5 times 3. 15 plus 1, 16. So you got 2 over 16 over 3. Again, you're just going to take that 3, multiply it on top. So you got 6 over 16. What's that reduced to? What'll go into both 6 and 16? This time you'd be right, Christopher, if you said it. 3 over 8. What do we notice about all 3 of these? They're all the same. So the angles were congruent, sides are proportional. So yes, are similar. Yes, these shapes are similar. Next question. Next question. 20. Sorry, I was thinking about something else. Problem 20. And again, what we covered today, and then my triangles probably don't look a whole lot like what they have there. But what we covered today, you won't have to go through as much to prove that the triangles are similar before you actually do the work. As a matter of fact, proving triangles are similar, a lot easier than proving that they are congruent to each other. Everything. We want to find GF, and we want to find EG. All right, what we're going to cover today to prove that these two triangles are similar, if this angle's 27, that angle's 27, we know that those two angles are congruent to each other. This angle's 110, that angle's 110, we know those two are congruent. And the easiest way to prove two triangles are congruent to each other is by a theorem called, anybody have a guess as to what that theorem's called? Angle-angle theorem. Right? So angle-angle theorem proves that two triangles are similar. If you can prove two angles in one triangle congruent to two angles in another triangle, then those two triangles have to be similar. And that's the one that we're going to use about 90% of the time because it's so easy. Now, you didn't know that theorem yet, so if we look at these and these two are congruent, and this one's 43, what do we know about angle G right there? It's got to be 43. We match them up, make sure you match up the two triangles. So here R matches up to E, T matches up to F, S matches up to G, and when you match up the segments to set up a proportion, make sure you're matching them up correctly. Pick a side in triangle 20, or I'm sorry, in triangle RST, over here by the 20. RS. RS is 20.7. So I put that on top. What's it match up to on the other side? EG. Do we know what EG is? No, they put an X over here. I'm not sure why they didn't put a letter over here. We'll put a Y over there. Doesn't matter. Pick another side from that triangle. 15. That's going to go on top here. What's it match up to over here? Now, when you do this, when you're matching it up, and probably the biggest problem most of you is going to have when you're doing this is you've got to make sure that you pick two sides that have numbers in them. All right? This is going to give you, if we did this on the calculator, reduced it down, that would give you your scale factor. That's telling you how these two triangles are related to each other. So we want to make sure that we pick one of those. We multiply the extremes. Somebody help me out. What's 20.7 times 11.25? I'm going to start checking calculators starting Friday. Got to bring a calculator.
232.
So have it out.
0.875.
0.875. That's going to equal the means multiplied together. What's y times 15? 15y. How do we solve that? Divide both sides by 15. what's y equal?
15.525.
And y was actually EG, so that's one of our answers, 15.525. One of the things they ask us to find. Now find the x, I'm just trying to, oh, they wanted us to write the similarity statement too, we'll do that at the end. We want to find x, what's that mean? We're going to have to set up another proportion, right? Only this time we want to stick x in there. When you set up this other proportion, you're still using the same two triangles. Use that ratio right there. That's where you're going to start at. We already know that it has both numbers in it, so we're going to use that exact same ratio over again. Now, which side over here matches up to the x over here that we want to put in this second one? So 10 over x. We cross multiply, we get 15x equals 10 times 11.25. Remember, you just bump the decimal over one place, so it's 112.5. Somebody help me out, what's 112.5 divided by 15? 7.5. And that's x, that's GF, that was part of our answer. That's one of the things they wanted us to find. 7.5. Sometimes, if it was x plus 3, you'd have to plug back in there and add on the 3 or whatever to find it. So we got this, we got this. I think they asked us to find x also, which is that. And the other thing they wanted us to do was write the similarity statement. All you're doing is just, like when we were writing the congruency statement for two triangles being congruent, you're doing the same thing, except now we're going to say that they're similar. Name this triangle for me. Triangle what? SRT. And we're going to say it's similar. Remember what your similar statement is, don't put congruent in there. It's a triangle. What's the S match up to in that triangle? G. What's the R match up to? E. And what's the T match up to? F. So that's the other part of the answer that they want. So 4 parts of the answer. The 2 segments that they ask us for, the fact that which 2 triangles are similar, and make sure that we got them matched up, and what x was. Problem 32. Says determine whether each statement is always, sometimes, or never true. And the statement is 2 obtuse triangles are similar. So if I have 2 obtuse triangles, somebody give me a measure for this angle right here. That's an obtuse angle, would make that an obtuse triangle, right? Give me a measure for this angle.
91.
Say it again.
91.
91. That's an obtuse angle, would make that an obtuse triangle. Are these 2 triangles going to be similar to each other? Remember, corresponding angles have to be what to each other? Congruent. Is there any way that one of these other 2 angles is going to be congruent to that 110? No, because a triangle can only have one obtuse angle. So, can these 2 triangles ever be similar? No, but if we would have stuck 110 in there instead of 91, then could they have been similar to each other? So what's the answer for this one? Sometimes. Sometimes. 38. Going by what we've already said today, what do you know about these two triangles? Similar to each other. Got two angles, so they're going to be similar. Pick out two sides that match up that we know so we can set up a ratio. 20 matches up to the 15. Before we go any farther, if we wanted to do the scale factor, you take that and just reduce it down. And that's going to make things a lot easier if you find those two numbers that you know for sure that match up and you reduce it, because then the numbers aren't going to be so big. What will go into both 20 and 15? 5 will go into 20. 5 will go into 15. So the scale factor of these two triangles is 4:3. So we can use that ratio to set up with another ratio to solve for anything in these two triangles. If we want to solve for x first, then we're going to put 2x on top over here. What's it match up to? Multiply the extremes. What's 4 times 12? 48. Multiply the means. What's 3 times 2x? Divide by 6. So what's x equal? 8. We go to set up to find y. Is that all they wanted to find was x and y?
Yeah.
We go to set up to find y. We're going to use the same ratio right here. That's our scale factor. We can use it for any proportions we set up for these two triangles. So 4/3. Now what are we going to pick? What's going to go on top here? 12, right? You've got to make sure if we start here and go 20 to 15, then we got to go here to here. It's got to match up the same. So 12 over y plus 4. We said last time, anytime you, or a couple times ago, anytime you have something like this, put parentheses around it before we multiply. So we got 4 times y plus 4 equals, multiply the means. What's 3 times 12? 36. Distribute here. 4y plus 16 equals 36. Subtract 16. Why does it keep disappearing like that? Divide by 4. So we end up with y equals 5. That's what we're going to be doing for most of the rest of the chapter. Setting up and solving proportions using similar triangles. All right, let's go ahead. We'll do this assignment. Shouldn't take you 15 minutes. Hopefully, it's only like 5 problems. Hopefully, you'll have it done before then so we can move on. Page 295, 34 to 37, 62, and 63. You can work with a partner. Hopefully it'll only take you about 10 minutes, then we'll go on to today's lesson. So we're going to cover similar triangles. Be able to identify similar triangles. Again, we're going to learn easier ways to show that two triangles are similar. You're not going to have to go through all the stuff that we went through last time. Use those similar triangles to solve problems, just like you were just doing on that in-class assignment. And indirect measurement. Different ways to use indirect measurement. There's a mirror method, there's a shadow method, another shadow method, and we'll talk about those when the time comes. Haley, will you do me a favor and go back here and just click on the screen, since apparently it won't let me do it now. I don't understand why. Oh, forget it. There we go. All right, you don't have to write any of this down right now, but in your postulates and theorems section at some point, get started copying the chapter 6 postulates and theorems. And we're just going to run through them very, very quickly here. 6.1, this is the one that we're going to use most of the time. I thought it was a theorem, but it's actually a postulate. It's the angle-angle postulate. At the end of the year, when we take the final exam, don't get any of these postulates or theorems confused with the congruency postulates and theorems. All right? These are all ways to prove triangles are similar. These are ways to prove triangles are similar to each other, not congruent. This is the one we're going to use most of the time. So if I have two triangles, and I know this angle is congruent to this angle is congruent to this angle, that's enough to tell me those two triangles must be similar, and I can match up the corresponding sides and set up proportions. This is the one that we're going to use by far the very most. The theorems, 6.1. Side similarity theorem. On that one, we're not going to use it near as much, because what it says is that all three sides of one triangle are proportional to all three sides of another triangle, then those two triangles must be similar. Well, if they're proportional to each other, is there going to be a whole lot of math work for us to do? No, we're already going to know all three sides in both triangles, and there's not a whole lot to do, so we don't use that one quite as much. Anybody guess what that one stands for? Side angle side. Now with this again, you got to remember that the sides are proportional to each other, but the angles are what to each other? Congruent. Alright, so don't forget that. Sides are proportional, angles are congruent. 6.3 says similarity of triangles is reflexive, symmetric, and transitive. I'm not going to write all that down again. All they're saying now, same thing we said when we were talking about congruent triangles. If two triangles are congruent, then we know that it fits all three of those properties: reflexive, symmetric, and transitive properties. We're not going to talk about 6.4 and 6.5 today. We're going to do them later. Also 6.6. And I think the two corollaries, we're going to do them in a separate section also. I don't even see those in here. They're in here somewhere. See if I can find them real quick. Make sure I didn't skip over them. What are corollaries while I'm trying to figure them out? Anybody know what a corollary is? What did I tell you about corollaries? Same as postulate. Axioms, corollaries, postulates, all basically the same thing. They're something we just take for granted to be true. I really didn't do too much of that. Angle, we just talked about that one. Side, side, side. All three sides one triangle, proportional to all three sides another triangle, not congruent, proportional. And then the last one, side, angle, side. All right, the angles are congruent, sides are proportional. Again, we're probably not gonna have, I'm not gonna have time to go through all this. This is what we were gonna do. We're gonna do this in class together. Look online. I'll have that video online. After you watch the video of me doing these first 5 problems, then you should be able to do the worksheet, okay? And also there's a quiz. There's a quiz that you need to do online after the video. So do the quiz after you watch the video. And that quiz will be put directly into Moodle as a grade. You're going to be doing the same things that you were doing, setting up proportions. All these, everything on these two, setting up and solving proportions. Again, 1 through 5 on 310. It goes 309 is one of the pages, and on the back is 310. 1 through 5 on 310 is what will be on the video. You can watch.
So we have to do the full page or?
Yeah. It's not very hard once you get started doing it. There's only like, what is there, 16 problems, and I'm going to do 5 of them for you. So 11 problems.
Now what if you don't use the video?
Oh, if I don't,
Yeah, so try it.
yeah, still try it. It's not, you're setting up proportions just like we were doing on that in-class assignment. I will get it. Yes, I will. If, for some reason, I don't have the video, I should have it done before intervention, so if you got on there and looked at it before intervention, you could see it on there. If I don't have it by then, check tomorrow. It will be on there. I won't go home tonight until it's on there. Yeah, probably best. That way I can make sure I got it written in.
What?
She give me another watermelon.
What? If, here, come here, I'll just write it down. If you get on Moodle and look at it, there's an in-class assignment and a regular assignment on these 2 pages. If you go on there and you look at the notes for 6-1, I believe. If you get on Moodle and you open up the notes for 6-1, it'll tell you. If you go down to the slideshow, it'll tell you. If something happens, you can't figure it out, then come back to me. Travis, you have a question?
I left all my crap right in front of my door. So, I left all my crap outside in my door. Outside of your house? Yeah.
So you live with this.
Outside.
No quality is more important to me. So you don't have anything else going on, so that's like, you're like saying, all right, Mr. Eversole, I'll stay and get caught up because I don't have anything else. You're not very important, Mr. Eversole, so if I had anything else going on, I wouldn't stay with you. I'm just kidding because it.
Person, I bet.
What's your-
All I got.
I probably didn't do it either.
Oh, no, maybe it's
I think I guessed.
I didn't do this one right here, dude.
Uh,
No, I straight messed that up, dude. I put question mark for that.
Where's mine?
You'll be able to come down.
Okay, this one.
You probably have to set and wait for about 20 minutes.
Don't do shit.
Come in, set it. Because I have a.
Tristan's right for this class. I got that. Dude, I just want next class to be over with already, dude. What? Get it done over. Yeah, knock it out of the park. Get it over.
Johnny, did you go to
Ag practice?
Yeah.
No, we canceled.
Yeah, I didn't know if you knew that or not.
I got on the AET, dude. I'm not stupid.
I wasn't even thinking about going. I was like,
Oh, and I got a watch.
I'll just change your pockets.
Oh my god.
And I got
We did all of it. I gotta look at my test.
You got about 5 minutes to make sure your tests are finished before I collect them.
It's a change out here. I'm crazy now.